Welcome to another, I know you're surprised, but another lecture in physical science about the periodic table. Today we're going to explore it in a little bit more depth. We're going to dive into what are ions basically, and how those ions are being affected. And we're going to dive into the different categories of the periodic table: metals, non-metals, and metalloids, and maybe rebels, Jedi, creatures, ships, bounty hunters, aliens, empire, planets, and droids. Maybe, maybe not. Let's talk about what we've got today. Our objectives: to determine the number of protons, neutrons, and electrons in an ion. We're going to talk about ionization, and we're going to go into how an ion is formed and what that means to us. We're going to describe the properties of metals, nonmetals, and metalloids, also known as semiconductors. So, first of all, an ion is an atom that has either lost or gained electrons, and so they are trying to typically get full valence shells. Okay, the reason that ions form is because they are trying to get to a full valence shell, because they like full valence shells, because it makes them more stable. Now, anytime you hear me say the word "like" with regard to an atom, that's a bunch of baloney. Okay, atoms don't like anything, but we like to talk about things in human terms, and so it kind of helps us to relate to the atoms if we say that they like something. But no, they just become more stable, lower potential energy states. So an ion is an electrically charged atom or group of atoms, and it's formed when when electrons are either added or taken away. And the process of making an ion is called ionization. Okay, so if I add electrons or remove electrons from a neutral atom, it's called ionization. Now, you guys have probably heard of ionization. There's some different, technologies that ionize the air. Okay, and you may have heard of that. That's a technique that is used sometimes to try to clean or purify the air, to get rid of ozone. All right, group 1 elements are forming positive ions. Okay, so if I look at group 1 in the periodic table, right here, it's going to form positive ions. Okay, so you have all of these being positive, and they're going to have a positive 1 charge. Okay, now these elements are going to have one single valence electron easily removed. So imagine, if you would, that we've got an atom. I'm going to pull them over here. And so we've got lithium, for instance. And if you can take that lithium and you have that 1 valence electron, and you take that valence electron and you remove it, okay, you can see that disappearing, then what I've got now is 3 protons, which I had in the beginning, and I originally had 3 electrons, right? 2 electrons in the first energy level, 1 electron in the second energy level. And once I remove that 1 electron, I now only have 2 electrons in that energy level, okay? So now I've got 3 positives and 2 negatives, which means my overall charge of my lithium ion is now 1 positive. So if I were to write the symbol of lithium, it would be like this. It would just be Li with a plus sign on it, okay? That would be the lithium 1+ ion. So it goes from being neutral to being an ion, okay? That's the way the ions are formed. Okay, so that's with the group 1 element. What's going to happen to group 17 elements? Now, again, the reason that it's doing this is because it becomes more stable. 2 is a stable shell. It is a full shell when you are talking about just having 1 energy level. 2 electrons is a full shell. So if it can keep a full shell, that's more stable. But when you go over to the group 17 elements, you're actually wanting to get an electron to become a full shell, because the atoms are trying to get to 8 valence electrons for the most part, except for that first energy level, which is just 2. That's all it can hold. All the other energy levels are trying to get to 8 valence electrons, 8 octet, okay? And that makes it more stable. So here I've got some fluorine, and fluorine has 7 valence electrons. It's got 2 electrons in the first energy level, 7 in the second energy level. It's got a total of 9 plus in the middle, okay? 9 protons in the middle. Woo, woo! Ah, lost our marker. Okay. Then we've got, in this one, we've got 9 protons still in the middle, right? But we have 2 electrons in the first energy level and 8 electrons in the second. Now, how did we get 8? Because an extra electron came in, flew in, and was added to that energy level. Okay, it was added to that shell. Now it's more stable. And where did that come from? It could have come from from air, from space. It could have come from reacting with another element, and now they're sharing. But in one way or another, this fluorine atom now became a fluoride ion. Okay, so also notice that the metals on the left side of the periodic table, they go by their name. So it's lithium ion. The right side of the periodic table, you put an IDE ending to the name, so it becomes fluoride ion or chloride ion. So that's ion formation. Again, the idea is you're trying to get to a full octet. Lithium doesn't get to a full octet. It gets just 2, which is full for the first energy level. Sodium, however, which is the one below lithium, that would get to a full octet. Okay, that would get to 8 valence electrons. Okay, so cation is the name that we use for ions that are going to be positively charged. Okay, so I've been wearing a cation shirt the other day. It's a positive ion, right? Positive cat. If you like cats, it works out well. If you don't like cats, it might not. And then the negative ion is called an anion. Okay, it's an ion that has a negative charge. So the anion has one more, or maybe 2 or 3, 4 maybe electrons more than it should. A cation has 1, 2, 3, or maybe 4 electrons fewer than it would normally have, okay, in its neutral state. So if I were looking at, again, let's just kind of do sodium. How about magnesium? Let's do magnesium. Magnesium has 2 electrons in the first energy level. 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second energy level. And it's got 2 electrons in its last energy level, in its third energy level. Okay, and so what kind of an ion is magnesium going to form? Well, it wants to get to 8. The best way it can get to 8 is by getting rid of 2. So if it gave those 2 away to some other atom, maybe it gave them away to chlorine, for instance. Now magnesium has a 12 plus charge, and 2 plus 8 is 10 negative charge, and so its overall charge is 2 plus. So this would become a magnesium 2 plus cation. Does that make sense? So that's what you would have if you had a cation. Now let's do, let's see, I guess we're going to have to do chlorine on this one. So let's do oxygen or sulfur. Let's do sulfur. All right, so here's sulfur. And sulfur has 2 valence electrons in the first energy level. 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, or 8 electrons in the second energy level. And then its valence electrons, we've got to get to a total of 16, so we're at 10. And so it's got to get 1, 2, 3, 4, 5, 6. So now it's got 6 valence electrons. Remember, valence electrons are the electrons in the last energy level. And so if I've got 6 valence electrons, and sulfur wants to get to an octet, right? So in order to get to an octet, it can either get rid of 6 or get 2. Now, it's not likely any of the nonmetals are going to get rid of all the extra electrons that they have. That takes a lot of energy. It would be difficult. And yet, it actually is energy favorable for them to get a couple of electrons. So sulfur might just share with 2 other things, maybe even 2 oxygens or something, right? So sulfur is going to get these 2 electrons added to it. Okay, and because it got 2 more negatives, well, before it was a 16 plus, and it had 16 negatives, but now I've added 2 more. So now I have 18 negatives. Okay, so now 16 plus and 18 negatives is 2 negative, right? So this is a sulfur anion. It's a sulfur 2 negative anion. See how that works? Okay, so that's cation and anion. By the way, in case you were interested, there is another way. If you don't like cats, I like cats, so it's easy for me to remember. But if you don't like cats, you can make sure that, remember, cation is the positive ion, because you just make little X's, but pluses, out of that poor little cat. Meow, whiskers. Funky looking cat there. Anyway, those little pluses are maybe that's a dead cat, I don't know. Don't do that. Cats are good creatures. I like them. All right, so what I want you to do is now is I want you to take a minute. You're going to pause and practice. You're going to try and fill out this table. Now you'll notice that we have oxygen 2 negative, magnesium 2 positive, bromine 1 negative, and potassium 1 positive. I want you to try and figure out the rest of this table. Fill it out based upon what you see here as an ion. So you've been able to do this with atoms, but can you do it with an ion? Let's see. Pause it and practice. And we're back. Okay, let's see what we got. Well, the atomic number, remember, is always going to be the number of protons, and that doesn't change. Okay, so you just find the number of protons listed there, and you've got that. The mass number is the number of protons and neutrons. That's not going to change compared to normal, right? So just write down what they are, and you've got it. Now, number of protons. Well, that's easy because that's the same as our atomic number, right? You're like, man, Powers, give me a challenging one. All right, well, it gets a little more challenging here in a second. Number of neutrons. Well, we know how to do that. We just subtract, right? 8 plus 7 is 15. 13 plus 12 is 25. 45 plus 35 is 80. 19 plus 20, 39. Okay, now it's a little tricky. This is the tricky part, the number of electrons. Oxygen has a 2 negative charge, which means it has more or less electrons than normal. It's got 2 more minuses. Electrons are the minus things, right? Electrons are the negatively charged things, so it's got 2 more of those negatively charged things. So if it normally has 8 electrons, it's got 2 more than normal. It's now at 10. Okay? Magnesium, it's a 2 plus. Normally has 12 electrons, but it's got 2 more positives than it has negatives, which means if it normally has 12 negatives, it's got to have 10 negatives now, right? So 10 electrons. Bromine, 35. This is bromine minus 35 protons normally, but it's got 1 more negative than it normally has. That means it's got to have 36 electrons. Potassium, 19, but it has 1 plus. Normally has 19, but it's got 1 more positive than it has negatives than it should, and it should have had 19 negatives. Therefore, it must be 18 negative. Okay, so 18 electrons. See how that works? How'd you do? Did you rock it? I hope so. All right, let's go on to the next one. Now let's talk about the magnesium atom versus the magnesium ion, and let's see if we can answer these questions. Just a couple little questions we want to talk about. How many protons and electrons are each of these going to have? Right? So we know protons, 12 protons, and 12 electrons for a regular neutral atom. For magnesium ion, 12 protons, that hasn't changed, but it's got 10 electrons, right? Because it's got 2 more positives than negatives. Which is more reactive? Well, remember, this is trying to change into this. So this is going to want to react. This is going to react. This is not reactive, okay? This is the one that's not reactive, all right? Now, which is found in nature. Oops, that button, wrong one. Going the wrong way a couple times. Oh, I'm just going all the way the wrong way. And we're back. Okay, which is found in nature. Well, this one is really reactive, so it wants to immediately react with something. As soon as it has the opportunity, it's going to react to something. And so this one is not going to be found in nature naturally. You're not going to find magnesium in nature. Not by itself. You're not going to find perfect, pure magnesium. However, you will find the ion in nature. The ion is going to have given away its electrons, and now it's going to be found in compounds. So you'll find magnesium ion found like magnesium chloride, right? Where it gave one of its electrons to one chlorine and another of its electrons to another chlorine. You'll find it in compounds all over the place in nature. That's what's found in nature is the compounds, okay? You won't find pure magnesium in nature. You'll only find it in the form of compounds because this one is so reactive, it reacts to form that. And so now this ion, it's like, I'm stable. I'm with chlorine. I'm happy. I'm not reactive now because I'm with chlorine, and chlorine is making me happy. It gave me took my 2 electrons and made me stable because now I have 8 electrons in my valence shell. So that's how these ions kind of work, okay? Okay, now let's talk about how elements are classified. We'll wrap this lecture up off of this part of metals, nonmetals, and metalloids. So elements are classified into which 3 categories? Well, I just told them to you, right? We've got metals, nonmetals, and metalloids. And we'll see a picture of that here in a second. Where is the location on the periodic table? We want to talk about where that location is. I'll bring up the periodic table here in a second. We want to talk about their general properties, right? This is kind of reviewing what we're going to talk about here in a second. And then in our group 1, what's the name? What's the reactivity? What's the uses? We're going to go into all the different names and the reactivities of all of the different elements, a little bit more into section 5.3. But let's talk about our first 3 categories. We've got our metals, nonmetals, and our semiconductors, or our metalloids. Our metals are great conductors of heat and electricity. They are ductile, they are malleable, and they are shiny for the most part, okay? Examples are like copper and lead. Nonmetals, poor conductors of heat and electricity. They are not malleable, they'll be brittle instead, okay? They're not shiny. They're typically going to be, things like sulfur, which are not, or carbon, which are not really that shiny. Carbon's actually a little bit shiny in the graphite form, okay? And then we have our semiconductors. These are actually going to have kind of a mix between the metals and nonmetals. They're going to be good conductors of electricity under particular circumstances, okay? They are used in like computer chips, silicon, for instance, and other types of electronic devices. And so this is what we want to talk about. Which category has the most elements? If I look at this periodic table here, which category has the most elements? Well, my metalloids are right here along this stair step, okay? So basically, this is a metalloid, that's a metalloid, those are metalloids, that's a metalloid, that's a metalloid. So I've got 1, 2, 3, 4, 5, 6 metalloids. All right, not too many, huh? And so everything to the left of this, all of that is considered a metal. We have some nonmetals, and they're right here, okay? So these are our nonmetals. Okay, those are our nonmetals. And so everything else is metals. So all of that's metals, a little bit of metalloids, and some nonmetals, okay? So that gives you a little picture of what you're seeing. Now let's see if we can answer those questions. What were those questions again? Oops, went too far. Right? Went the wrong way is what it did. Okay, let's look at those questions again. Which category has the most elements? Now you can answer. Metals, right. Which category has the least elements? Metalloids, good job. What's the only nonmetal on the left side of the periodic table? Uh-oh, we have to look at the periodic table for that one, aren't we? The only nonmetal on the left side of the periodic table. Okay, so let's go back to that screen and see. You see anything over here that could be a nonmetal? I told you everything's over here is metal, but there's one that's not. Okay, it's this one right here, hydrogen. Now, in the center of Jupiter, they actually believe that hydrogen is so highly compressed that it actually turns into a liquid metal. And it actually has the properties of a liquid metal, kind of like mercury, at the center of Jupiter, where the pressures are just so vast. So they've actually replicated something similar to that in a laboratory. And so in some ways, it's kind of like a metal in very certain crazy circumstances. But for the most part, yeah, this is going to be non-metal. It's going to behave like these guys over here. It's going to be a gas, right? And it's not going to conduct heat or electricity, et cetera, et cetera, et cetera. So it's going to have the properties of non-metals. The reason that it can kind of be over here and over here is because it has one valence electron, so it belongs over here. But it also would like to have one more valence electron and be full and be like helium, okay? So it kind of belongs like these because all of these guys want to get one more valence electron and be like the noble gases. All right, last little bit and finish up here. Metals versus nonmetals. Again, just a little reminder, review. Metals are going to contain less than 4 valence electrons. They're going to lose electrons and form positive ions, the cations. Metals are forming cations. And again, we're talking about 4 because it's kind of right in the middle. Carbon, they could kind of go either way. That carbon group or that group 14, they could go either way. Nonmetals contain more than 4 valence electrons, and they are going to gain electrons to form the negative ions called anions. Let me show you that again. Here's my group 14 right here. Carbon, right? And so everything from this side, they all want to form ions. They're going to be negative ions. It's going to be 3 negative, 2 negative, 1 negative. These guys are not going to form ions. Okay, they're happy already. On this side, these guys are going to form 1 positive, 2 positive, and then 3 positive. Now, this whole middle section here, all this D sublevel stuff, okay, these are going to form typically 2 plus, 3 plus ions, okay, sometimes a 1 plus ion. So basically all of these are going to form positive ions. They're going to be cations, but you cannot predict specifically what type of ion they will form based upon the column they're in. See, the nice thing here is that this is group 1, this is group 2, 1 plus, 2 plus. This is group 13, it's a 3 plus. You see the 3 and 3? This is group 15, 15 and 3 is 18, right? Or 5 and 3 is 8. Okay, this is 16, 6 and 2 is 8. This is 17, 7 and 1 is 8. So you can figure out how the column associates with the number of valence electrons. 17, I just need 1 more to become 8. Okay, remember this is 18. These guys have 8. That's why they don't need anything. Okay, now carbon, that whole family there could go either way. And so sometimes we'll say that could be a +4 or a -4 because sometimes they might gain some, sometimes they might lose some. It depends. All right, so I think we can check our objectives now and see if we have learned something amazing today, and I think we have. We have now been able to figure out how to determine the number of protons, neutrons, and electrons in an ion, okay? Not just in atoms, but in ions, where we have more or fewer electrons. And then we can talk about the properties of metals, nonmetals, and semiconductors, okay? We know those properties now, and we know where they are in the periodic table, too. I hope you have a great day. I hope you enjoyed learning a little bit more about the periodic table and the amazing elements that make up our world. God bless you.